Hello friends, I am Pratima. I welcome you all to my channel. I thank all the subscribers. So this is a IMO question based on number theory. Let's see how we can solve it. Determine all the pairs of x, y of positive integers such that x square y plus x plus y is divisible by x y square plus y plus 7. That means x y square plus y plus 7 divides x square y plus x plus y. Now to simplify, I am multiplying. Let's multiply the divisor with x and the dividend y. That means I am getting the divisor x into xy square plus y plus 7 and y times x square y plus x plus y. If xy square plus y plus 7 divides x square y plus x plus y, it is equivalent to xy square plus y plus 7 divides y times of x square y plus x plus y minus x times of xy square plus y plus 7, or x y square plus y plus 7 divides x square y square plus xy plus y square minus x square y square minus xy minus 7x. This is equivalent to xy square plus y plus 7 divides y square minus 7x. That means y square minus 7x is a multiple of xy square plus y plus 7. Now, what are the cases of y square minus 7x? Y square minus 7x can be greater than 0. Y square minus 7x can be equals to 0. And y square minus 7x can be less than 0. We are going one by one. If y square minus 7x greater than 0, then in order to have above divisibility, this one xy square plus y plus 7 should be less than equals to y square minus 7x. But it is not possible. It is not possible. Why? As x and y are both positive. So y square minus 7x cannot be greater than xy square plus y plus 7. Second case, if y square minus 7x equals to 0, that means y square equals to 7x. So here many solutions can be possible. Let x is equals to 7 times of m, when m is an integer, positive integer, then y square equals to, it will be 7m square I am taking, so that I will get y square value. So y square is equal to 49 m square, or y equals to 7 times of m, when m is an integer, positive integer. So here the solutions xy equals to 7 times of m square and 7 times of m when m is a positive integer. Then coming to last one, if y square minus 7x is less than 0, that means 7x minus y square is greater than 0. That time this divisibility can write 7x minus y square equals to some multiple time, let us take this d, xy square plus y plus 7 when d is a positive integer. This x in term of y, so this will be 7x minus y square minus dxy square plus dy plus 7d, or we get 7x minus dxy square, taking x together, it will be y square plus dy plus 7d, or taking x common, 7 minus dy square equals to y square plus dy plus 7d. Here RHS is positive because we have taken d as positive and y is given to be positive, as y and d are positive. So left side must be positive. When left side is positive, that means 7 minus d square greater than equals to 0, or 7 is greater than equals to dy square. Y is positive, d is positive, and dy square is less than equals to 7. So what should be the value of y? Only on this condition y equals to 1 or y is equals to 2. Now if y equals to 1, putting in this expression, x into 7 minus d equals to 1 plus 8d, or x equals to 8d plus 1 over 7 minus d, or x is an integer, so I am writing in integer form, minus 8 plus 57 over 7 minus d. To get x as an integer, 57 must divide 7 minus d to get an integer. So the value of 7 minus d must be the divisor of 57, divisor of 57 are, the 7 minus d must be equals to 1 or 3 or 19 or 57. But 1957 cannot be the values, only otherwise x will be negative. So 7 minus d equals to either 1 or it is 3. So when 7 minus d equals to 1, that time x equals to minus 8 plus 57, that will be 49. So one solution we are getting x and y equals to 49 and 1, because y is 1 with 2. And if 7 minus d equals to 3, that time x equals to minus 8 plus 57 over 3, that will be 19. So this should be 11. So x, y, again it will be 59, 11, 1. The two possible values. And now the question is, if y equals to 2, what will happen y equals to 2? That time you will get integer value of d. So this is rejected. So what are the solutions now? Solutions of this question equals to 7m square, 7m, m is an integer, then 49, 1 and 11, 1. Thank you for watching. Please keep on watching.